Hello everyone. Okay, so in this video we're just looking at the transformation of functions. So we're just going to look at some transformations for a function. So let's first look at some vertical transformations. So if I add or subtract a constant term to my function, that would be shifting my function or translating my function up or down by that amount. So my functions will shift up or down. Again, there's no point me telling you. Let me show you on the GeoGebra. So we're at GeoGebra now. Right? Oop. Right. So we're on GeoGebra. So we want to add a constant here. So if I add a constant to this function, see now if I add -2, my function shifts down 2. Each point is translated down 2. If I bring it up, I add 2. So my function going up, I add 2. Bring it down, I subtract 2. Now, you're probably asking, what about if I want to move it left or right? That's what happens now if we add something in my input section. So if we add a negative number, that will shift it to the right. So see how I'm adding 1, -2, -3. It's shifting over that amount. So looking here, if I add 1, it shifts over to the left 1. If I add -2, it shifts it over to the right 2. The function shifts right, or left. Right? When added something there. Then another transformation that we look at in G-insert and leave insert is compressing and stretching of a function. So if I multiply my function by a number, it will compress the function in by a factor of c. So squish it in. And if I multiply it by a fraction, it will stretch my function vertically by a factor of c. So what's really important is to note, for these ones, the roots are the same. So the roots will stay same. So let's have a look back here at GeoGebra. So we're back here at my cubic here. So I need to change now this number in front. So I'm changing this a value here. So if I make it a 2 here, right, it kind of squishes in my function a tiny bit. It stretches it out, look. Stretch. Then if I multiply it by a fraction, it compresses it. Look, it makes it more flatter. But notice how the roots do not stay. The roots do stay the same. See how it does not? So sorry, I meant to say, you multiply it by a fraction, it compresses it. If you multiply it by a factor, it stretches it. Okay. Then, what about if I multiply the input by something? If I multiply the input by something, if I multiply it by a whole number, it compresses it in, squeezing like skinny. And if I see the values changing up here, then if I multiply it by like a fraction, it makes it wider. Right? It compresses it. Or sorry, stretches it out. This. But the roots here do not stay the same. Right, and finally, the last one we need to look at is if I multiply the whole function by a minus, it will reflect the function on the x-axis. Then if I multiply my input by a minus, it reflects it on the y-axis. So looking here, back in GeoGebra. So, and we get this back to normal here. 1. Right. So let's multiply now my number in front by -1. If I multiply by a -1, it should flip. So do you see how my function now has kind of flipped upside down? It's reflected along the x-axis. If I now multiply my input x here by a negative number, so I'm going to multiply that by -1. Now let me put this a back to normal. Then if I multiply this by a -1, this is now kind of mirrored on the y-axis, right? So I think the transformation for a cubic actually is the same, is it? -1. Yeah, it looks more or less the same for a cubic, at least. That means put that here. It's not quite exactly the same. But all you need to know is, right, if I multiply my function by a negative number here, it flips it. So see how it's flipping on the x-axis? Flip. And then if I multiply my my input by a negative, it will flip on the y-axis. So like, flip, flipping on the y-axis. And there you go. Right, so let's just look at some questions really quick. Oopsies. Look at some questions really quick. So there's a QR code there if you want to scan and mess around with the function transformations yourself. So given the function f of x, sketch g of x, which is f of x plus 2. So g of x is, I'm adding 2 to my input. So if I'm adding 2, I'm going to the left. So I'm shifting points over to the left. So this point will now be over here. This point will now be over here. And this point will now be over here. So g of x is going to be equal to this. So I shifted it all over to the left. And then finally, h of x is f of x minus 1. So I'm subtracting by a constant, right? So I'm going to be moving my function down 1. So this is now going to go here. To this point now will go down here. And then this point here will go down here. So this is now going to be boom. Boom. That is h of x. That's being moved down 1, and then g of x is being moved to the left. Right, this one here, I think this one is a cosine function. So, given the function f of x, sketch g of x, which is f of x minus 3, and h of x, which is f of x plus 2. So I'm just going to do h of x first. So that is going to be, I'm going to shift every point up 2. Right, so that point goes up to here. This point goes up to here. This point goes up to here. This point goes up to here. Right, and then this point goes up to here. Point goes up to like here. Right, that should be enough. And then it's gonna look like we're adding 2, yeah. So 2 to 2. Right, so there you go. I made a boo-boo. Made a boo-boo, but did I make the boo-boo? Oh, that's 1. Sorry, I'm adding this to 3. Right, so we have here, this is what Right, so let's get to this one here. Given f of x equals f of x, sketch this function. G of x equals f of x minus 3. So I'm going to be shifting now this function 3 to the right. So let me just write some key points here. Boom, 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 boom. So I'm going to be shifting these 3 to the right. So this is going to be roughly 1, 2, 3 over here. 1, 2, 3 is going to be roughly here. 1, 2, 3 is going to be roughly here. 1, 2, 3 roughly here. 1, 2, 3 roughly here. 1, 1, 2, 3 roughly. So this is actually going to be right. I shifted all my points over 3. And then finally, h of x equals f of x plus 2. So I'm adding 2 now to all of these points. So I'm going to be going up 2, which is 1 unit here. So it's boom, 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 boom. Green function here. Of x, I shifted it all up 2. Right. This one here, given the function f of x equals this, sketch f of x plus 1 and f of x minus 3. So f of x plus 1, I'm shifting all my points to the left. 1. To the left, to the left. So let's pick some key points here. This one is shifting, this one, and I'm shifting to the left 1. So it's going to be over here, over here, over here, over here, and over here. There it is there. That's g of x. And then h of x, we're shifting down 3. That's going to be 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And this is going to roughly equal to like this. Right? And that is h of x. My function shifted down. Right, let's look at this one here. This one looks like to be an exponential function. Plot g of x, which is f of x minus 1. So f of x minus 1, I'm shifting it down 1. So key point here is this one. So that'll be going down here. And then this point will be going down here. So my exponential function is going to look like that. G of x shifted down 1. And then finally, minus f of x. That means it's going to be mirrored on the x axis. So literally, I flip all my points. Ding, ding. This remains the same here, and it's going to look like that. Right? Really h of x. So remember, only ever sketching these, right? Sketch, so not to be perfect. Right, let's look at these exam questions really quick. Draw on the graph a system of 2023. So the function g of x is defined in the domain minus 2 to 2. The graph is shown in each of the 2 diagrams below. Draw the graph g of x minus 2 on the coordinate diagram below. So g of minus 2, I'm shifting down 2. So this point goes down to here. This point goes down to here. This point goes down to here. So it's going to roughly look like that. That's g of x minus 2. Then now we want to do g of x plus 3. So now I'm going to be shifting to the left. I'm adding 3. So it's going to be this point. It's going to be 3 to the left. It's going to be over here. This point, 3 to the left. That's going to be over here. This point is going to be 3 to the left. It's going to be over here. So it's going to be ding, dong. There's my function g of x. Right. And finally, last one here. The graph of the function g of x equals x to the power of x. That's e to the power of x. On the same diagram, draw the graph of the function h of x equals x to the power of minus x in the domain 0 to 1. So honestly, you could just use your table of values for this one. Right? But all we do know is we're minusing my input. So this is actually, I think, the inverse function, I believe. E to the power of minus x. But actually, you could just sub it in. Why wouldn't you just sub it in? Sub it in. I think it'd be looking like that. Oh, you know what? Let's check in the GeoGebra. Oh, look at that. Very nice. Right, GeoGebra. So we have e to the x, and then we have e to the power of minus x. So, as I thought, it's reflected along the y-axis here. So, but it's in the domain 0 to 1. So, actually, I was completely wrong with my sketch here. So, it would actually only look like this. So, we go back here. So, I was correct. This is going to be reflected along the y-axis, right? So, this is going to actually look like this. However, it says in the domain 0 to 1. So actually, I can ignore all that. Therefore, e to the minus x. And that is graph transformations. Hopefully that was some help to you guys. It's just something you have to mess around with, understand yourself. But I hope there's some help, and I'll catch you guys later. Bye.